In section 9.5, you learned how to factor an expression where the coefficient on the x squared term was 1. Section 9.6 asks the question, what if there's a coefficient other than 1 in front of the x squared? In other words, in this section, we're going to factor expressions that look like ax squared plus bx plus c. In order to do this, it's helpful to remind ourselves, how does using FOIL to multiply two binomials together give us an expression that looks like ax squared plus bx plus c? Let's take the example shown below, x minus 3 times 2x minus 1. When we apply the FOIL method, we multiply the first terms together, and we get 2x squared. We multiply the outer terms together, and we get minus 1x. We multiply the inner terms together, and we get minus 6x. And we multiply the last terms together, and we get plus 3. Then we combine the outer and inner terms. They're like terms, they have the same degree. And so we get the expression 2x squared minus 7x plus 3. This is in the form ax squared plus bx plus c. In this expression, the value of a is 2, it's the coefficient on the x squared. The value of b is negative 7, and the value of c is 3. So if I'm trying to factor a trinomial of the ax squared plus bx plus c form, I know that I'm going to break it up into the product of two binomials. The first thing I need to do is look at the expression and see, are there any factors that are common to all three terms? If there's anything I can factor out of all three, I should do that first. In the example above, there is no common factor between all three of the terms, so I'm ready to proceed. I know that I'm going to be able to break this trinomial up into the product of two binomials, something x plus something times something x plus something. Step 2 is to figure out, in these two binomials, what are the signs going to be? Is it going to be something x plus something, something x minus something? Where do the pluses and the minus go? In order to figure this out, I'm going to look at the last term in my trinomial. I notice that in this case, the last term is minus 5. I know then that when I use FOIL, the numbers that go in the blue blanks above are going to need to multiply together to give me a negative answer. When I do that L in FOIL, the result needs to be negative. When two numbers multiply together and the answer is negative, it means one of them must be positive and the other one must be negative. So I know that the factored form of this expression is going to be something x plus something, and I still need to figure out what goes in those blanks, times something x minus something. The next thing that I need to do then is I need to do some guessing and checking. This is the first method I'll show you to figure out what goes in those blanks. I know that when I use FOIL and I multiply the first terms together here, whatever goes in those two yellow blanks is going to have to multiply to 3. Because when I do FOIL, the first terms multiplied together give me the 3 in the 3x squared expression above. So I know that I'm going to need to identify factors of 3 to go in those yellow blanks. I could put 1 in the first blank and 3 in the second. I could put 3 in the first blank and 1 in the second, and those are really my only choices. Now in FOIL, I'm going to skip ahead and look at the last terms. When I multiply the numbers in the blue blanks together, the answer is going to have to be 5. So in those two blanks, I'm going to need factors of 5. It could be 1 in the first blank and 5 in the second. It could be 5 in the first blank and 1 in the second. Now I've identified combinations of numbers that need to go in the yellow and the blue blanks. And what I need to do is check different placements of those factors. So one possible factorization using these yellow and blue numbers looks like this. I could have 1x plus 1 times 3x minus 5. Notice that the numbers in yellow in this are factors of 3. That ensures that when I FOIL these expressions together, my first term is going to be 3x squared. And the numbers in blue are factors of 5. Because I had already put a minus sign in, this ensures that when I multiply the last terms together, I'll get negative 5. So I know that the F and the L in FOIL are going to come out correctly. What I have to do now is to check the outer and inner terms. I need to check the OI in FOIL. If I check the OI, what I notice is that the outer terms together multiply to give me negative 5x, and the inner terms multiply to give me 3x. When I add those together, negative 5x plus 3x, I get negative 2x. When I compare this to my original expression, that's not the OI that I'm looking for. I'm aiming for 14x. What that means is that my guess of how this is factored isn't correct. I need to go back and look at the factors of 3 and the factors of 5 and try rearranging some of those to give me a different factorization. What I'm going to do is I'm going to leave the factors of 3 in place as they are. I'm going to leave the yellow numbers, but I'm going to switch around the blue numbers, the factors of 5. This will make my possible factorization look like this: 1x plus 5 times 3x minus 1. I just switched the 1 and the 5 in the factorization. Now when I check the OI in FOIL, when I multiply the outer terms together, I get negative 1x, and the inner terms together, I get positive 15x. When I combine those like terms, I get 14x. That is, in fact, the OI that I'm looking for. So the correct factorization of this expression is 1x plus 5 times 3x minus 1. In this case, it only took me 2 guesses to get to the right answer. Sometimes it's going to take you more rearranging of the factors, more guessing and checking to get this right. Please pause this presentation for a moment and you practice factoring the expression above. 4x squared minus 9x plus 5. When you think you've got it, resume the presentation. We'll go over this together in class tomorrow. What you should have gotten for this is 4x minus 5 times 1x minus 1. If you have these two binomials swapped in their order, in other words, if you showed 1x minus 1 first and 4x minus 5 second, that's okay because multiplication is commutative. A second method that I'll show you for how to factor a trinomial like this is called the break and group method. The break part is that we're going to break the middle term apart into two like terms that add together. The group part is then we're going to group the equation into two separate chunks that we can factor. I'll walk you through an example first, and then there'll be an example that you can do at your own pace. The first thing we need to do is to multiply a and c together. That's the first coefficient and the last number here. In this case, we'll take 3 times negative 5 and get negative 15. Now we take that answer, negative 15, and we look at the factors of negative 15. Negative 3 and 5, negative 1 and 15. These are all factor pairs of negative 15. I want to find the pair that adds up to the middle term in the original equation. In this case, I'm looking for a pair that adds up to 14. And I see that this pair, negative 1 and 15, meets that requirement. I'm going to take these numbers, negative 1 and 15, and use them to break the middle term up. Here's what this will look like. I'm going to rewrite 14x as negative 1x plus 15x. Notice that when I combine like terms, negative 1x and 15x, do in fact add to 14. The 3x squared and the minus 5 in the original equation come along for the ride. So I've rewritten the original expression. I've just broken the middle term apart. The two equations shown are in fact equivalent. That's the break part. Break the middle term up. The group part is that I'm going to group the first two terms together. I just put parentheses around them. And I'm going to group the second two terms together. I put parentheses around them as well. Now I look at these two groups and I ask, is there anything I can factor out of each group? In the first group, I notice that I can factor an x out. When I do that, what's left behind inside the parentheses is 3x minus 1. In the second group, I notice that I can factor out a 5. And when I do that, what's left behind in the parentheses is also a 3x minus 1. These factored expressions are still being added together. If you look at the two factored expressions, you'll notice that they both have a factor 3x minus 1 in them. I'm going to factor out the 3x minus 1 part, and when I do that, what's left behind in the first group is x, and what's left behind in the second group is 5, so x plus 5. Now I have fully factored the original expression. 3x squared plus 14x minus 5, which is what we started with, can be factored into x plus 5 times 3x minus 1. Now I'll walk you through an example of the breaking group method where you'll be able to fill in each step along the way. Here's the expression we're trying to factor. 2x squared plus 13x minus 7. Step 1. Multiply a and c together, being careful of the signs. What I want you to do is to write down the answers that would go in the blanks as you work through this presentation. I'll show you the answers before we move on, but this is a good place to check to see how your understanding is doing. Step 2, look at what you got when you multiplied a and c together and ask what are the factors of that number that add up to b, the middle coefficient in the equation. In this case, we're wondering what are the factors of a times c that add up to 13. Pause the presentation for a minute while you try and find the answers to these blanks. You should have gotten a times c is negative 14, and the factors of negative 14 that add up to 13 are positive 14 and negative 1. The next step then is to break the middle term up, this 13x, to break it up using the factors of negative 14 that we found. So the question is, what goes in the two blanks here where we break the 13x apart? Use your answer from the previous slide to fill in these blanks. Then we're going to group the terms in the step above into two sets of 2. We're inserting parentheses here, and the numbers that you inserted in the blanks above will carry through. So what you should have is 14 and negative 1. Those are the factors of negative 14 that add up to positive 13, and they carry through